What's up, students? I thought we would take a few minutes today to kind of talk about the last piece of the puzzle, if you'll pardon the pun, for plate tectonics. And this one, you guys, is plate relationships and results. So this is what you know so far. You know that the Earth's lithosphere and crust are broken into something called plates. You know these plates move because of convection currents in the asthenosphere. You know that these plates move in lots of different directions and that plates can be really big or really small. And so now what we do, we take a closer look at the relationships between plates. And when I'm talking about relationships, what I'm talking about is this right here. Is that plate relationship refers to what's happening to two plates that are right next to each other, okay? So these are plates along what we call a plate boundary, all right? One thing I need you to understand is that plates will either move away from each other, which is known as divergence. They'll move together, which is known as convergence, or they'll slide past each other, which is known as a transform boundary. So that's the thing that you want to know and remember as far as plate relationships. There are essentially three relationships, okay? Now, what we're going to do is take a couple of minutes, you guys, to look more closely at what these boundaries are doing and what kind of plate we're dealing with. Because if you remember, you guys, we have two different types of plates. We have oceanic plates, which are very dense, very thin, made of basalt, and we have continental plates, which are not as dense. They're made of lighter rock. They are not nearly as thin, and they're made of rock like granite. Okay, so first, you guys, let's talk about plates that are moving away from each other. So when we're talking about that, we're essentially talking about plates that are moving away from each other. They can be either ocean plates or we can have continental plate diverging. And they're slightly different and they result in slightly different things. So we're going to talk about that right now. Here we go. All right, first off, you guys, let's talk about the divergence of two ocean plates. So in other words, you guys, this is two ocean plates moving away from each other. The best example of this, and I'm going to start with the example because these are things we've already talked about. The Mid-Atlantic Ridge, you guys, is the best example on the planet of two ocean plates moving away from each other. Iceland, which you guys have already found in a map, which is in the North Atlantic, Iceland, you guys, exists because of this type of divergence, okay? You have two plates moving away from each other. And as a result of that, magma is allowed to rise. It rises, it gets towards the surface, that magma cools to form hard rock, okay? So as a result of that, as more magma comes up, as you can see in this drawing right here, this rock gets pushed out of the way, so we're actually making the Atlantic Ocean bigger, and as a result, the Pacific Ocean is actually getting smaller, okay? Understand this. Iceland, you guys, is an island that forms because of these volcanoes along this big rift. Just know that because we have magma rising, we have volcanic activity. Whenever we have rising magma, we have volcanoes. That's kind of a tenet and something that you're really going to want to remember. So Iceland, you guys, is definitely volcanic because it sits right on top of an area underneath it that's got tons of rising magma. So yeah, it's super active, which is amazing, I think. All right. On the other hand, you guys, we have the divergence of continental plates. So one of the things you need to remember is that if we are talking about ocean plates, we're talking about stuff that's happening underwater. If we're talking about divergence of continental plates, it means this is stuff that's happening at sea level or above. And a lot of times what we see on Earth, it's not that there's two continental plates that are moving away from each other. It's a single plate that's being ripped apart by various forces. That the plate itself is actually being torn apart because of what's happening underneath it. And I'm going to go ahead and jump right to the examples. There's two really great examples of where this is happening. The best example on the planet is the Great African Rift Valley. And the second best example is the Rio Grande Rift Valley in New Mexico, which is happening right here in the United States. The difference is that the Great African Rift Valley is happening much faster. And what you have, and I'm going to go ahead and jump ahead so that you guys can see what I'm talking about here. Oops. Uh-oh, I have to do that arrow thing. What I'm talking about here is this. I'm going to go back to this map. So if we look at Africa, what's happening with Africa, you guys, is that it's moving in lots of different directions. And as a result of that, this area along Africa right here is being pulled in two different places, okay? As you can see, you guys, it's moving down this way, and it's moving up this way. And as a result, this part of Africa is being pulled at a faster rate than the rest of Africa. So that's what causes us to have that cool Rift Valley. All right, let's move back in time here. Oops, that's not what I wanted. That's what I wanted. So what happens, you guys, is that we have the plate that's getting ripped apart right here. This is really heavy rock. It drops down and it forms this big valley that you can see right here. This valley is what we call a rift valley. It's also volcanic in nature many times because the crust above it becomes very weak. Magma is allowed to move up. So we often, not only do we get water that fills up these valleys, but it's also often some sort of thermal activity or volcanic activity that goes with it. That's pretty common. Okay, next let's talk about convergent boundaries. Now, there were two types of divergent boundaries that we talked about. There's actually three different kinds of convergent boundaries that we see here on the planet Earth, okay? And these convergent boundaries, you guys, are two ocean plates that come together, two continental plates that come together, or on occasion, we have an ocean plate that comes together or converges with continental plate. Okay, so we're going to talk about the results of those three types of convergence. Let's start with when two ocean plates converge. Now, one of the things you have to understand is that when this happens, it's happening underwater. Okay, so notice this this drawing right here, because again, we're talking specifically about something that's happening underwater. We can see it right there. This is what we call areas of subduction, and this is the reason that Earth doesn't get bigger despite the fact that we are making new crust all the time at our mid-ocean ridges. It's because while that's happening, at the same time, this process is happening. Whereas you can see right here, the lithosphere is moving. It's being subducted under a plate, and as a result of that, this rock gets heated up. It starts to melt into magma. The magma starts to rise because it's not very dense, and as a result, we get a volcano. As this layers of lava build up and build up and build up and build up, eventually what happens is that all along this boundary, we form volcanic islands, because eventually this rock piles up high enough where it peaks out above the surface of the water, and we end up with this entire, what we call an arc of islands, right along where one plate is subducting underneath another plate. We also get something that's called the deep ocean trench. So the deepest places on the planet, you guys, like the Mariana Trench, they are the result of this kind of subduction. Okay? So again, you guys, the best examples of the places on Earth where we can find this are going to be these places right here. So we've got the Philippine Islands, the Aleutian Islands, New Zealand, and the Marianas Trench are all really great examples of the results of two ocean plates that are coming together. Again, one subducts underneath the other, and then the magma that rises forms these islands. The Philippine Islands, the Aleutian Islands, New Zealand, they are all islands that are made because of this. The Marianas Trench, you guys, is the result of that area of subduction because one plate is essentially pulling the other plate down. It's pretty cool. I think it's cool. All right, let's talk about the next kind. The next kind, you guys, is when we have the convergence of two continental plates. Now, in this case, you guys, we don't have volcanoes because what essentially happens is that we have two of these big, thick pieces of crust. They're really thick, they don't subduct, and as a result of that, it just crunches and goes pretty much straight up in the air. So the tallest mountains on the planet are the result of this type of convergence. And again, you guys, the tallest mountains on the planet, the Himalayas, the Alps, and of course, please note, you guys, these are not volcanic mountains. We do not have subduction taking place. At least we don't have deep subduction. There's no melting of the rock. It doesn't get hot enough. And as a result of that, there's no rising magma. If there's no rising magma, we do not have volcanoes. And mountains like the Himalayas and the Alps, you guys, they are not volcanic mountains. Now, do they cause a bunch of earthquakes? Yes, you guys, there are a ton of earthquakes in the Himalayas and the Alps, but not volcanoes. Okay, so just keep that in mind. All right, as far as the next type of convergence, it's when we have an ocean plate subducting, converging, and then subducting underneath continental plate. Because remember, you guys, this is when the result, it gets subducted very easily. On the other hand, this continental crust does not. So what happens is that this ocean crust subducts underneath. Again, it gets really hot down there. This rock melts. Magma rises. And the magma, you guys, rises and burns its way through the continental crust. So we're left with volcanoes that are on land instead of being underwater like they are when we're forming the Aleutian Islands when we have two ocean plates converging. Okay? And again, two of the best examples of this, the Cascade Mountains, which are in the northwest United States, so those big volcanic mountains we see, like Mount Rainier in Seattle, or Mount Hood in Portland, or Mount St. Helens, which is between Seattle and Portland. Those are all the results of this type of convergence. Okay? And then finally, let's go ahead and look at our last type. These are our transform boundaries. With a transform boundary, you guys, again, this is our last plate relationship. We have two plates that are sliding past each other. Now, this happens all the time in geology, but at a really small scale. That's how we get these little small scale earthquakes. What we have going on in California, you guys, is a really large scale massive boundary where we have essentially the Pacific plate, which is heading in this direction, and we have the North American plate, which is moving in this direction. And California, you guys, has this unfortunate existence. Part of California is part of the Pacific plate, and the other part of California is actually part of the North American plate. So like places like Los Angeles and San Francisco essentially sit really close to this massive boundary, and as a result of that, California is very earthquake prone because of this. So again, you guys, the San Andreas Fault, which is this massive transform fault system in California, is again the best example on Earth for us to find a transform boundary where we have one plate sliding past the other, and it's not a smooth transition. There's a ton of friction that builds up. Eventually, those rocks overcome the friction and they break, and there's a big release of energy. That's what we call an earthquake. And again, you guys, please notice this little thing right here, that with transform boundaries, we have lots of earthquakes, but we don't form volcanoes. And the reason we don't form volcanoes is there's no subduction, there's no melting of rock, there's no rising of magma, so there's no volcanoes. So there you go. And the last thing I wanted you to look at with these notes, you guys, is just this map. Because again, you guys, this map shows you all of these different relationships, okay? So for instance, you guys, if we look at the map right here, look, here's Iceland right there. And again, you guys, Iceland is this instance, and this is one of the dreams I have. I've always wanted to do this. You can actually go to Iceland. You can go to the middle of the country. You can dive in a couple of different little valleys they have that are full of water. If you deep dive down, you can actually touch each plate. You can put you can put one hand on the Eurasian plate, and you can literally put the other hand on the North American plate, which I think would be really cool. All right, so again, you guys, if we're looking at this, right here, this is going to be your Andes Mountains right here, where the Juan de Fuca plate and the North American plate come together. Those are the Cascade Mountains. I'm going to go ahead and move this out of the way so that you can better see this. Where the Indian plate comes together with the Eurasian plate, this is where I have the Himalayas. Okay? Just little incidences like that. Again, you guys remember where the Ring of Fire is? All of these volcanoes that we have in this area. And it's because, you guys, the Pacific plate is being subducted under lots of other plates. It's being subducted under the North American plate, the Eurasian plate, the Australian plate. As a result of that, you guys, we have a ton of magma, ton of volcanoes. That's why you have this huge incidence of volcanoes there. Okay? So there you go. That's about plate relationships. So that's stuff that you guys did on the map before we left for Thanksgiving. That's the stuff that that's why we took the time to talk about those things first, and we talked about it, we found these locations, and now we know why these locations exist and what's going on. Okay? All right, if you have any questions, let me know.